is the screencast for section 4.8, example 1. We will be solving problems with trigonometry. This section is a lot of review using right triangles and setting up trig, but we're also going to combine some heavier Algebra 2 material in here to solve for the variable that we need. A couple of points, a couple of vocabulary I want to mention. First, we're going to be dealing with an angle of elevation, which is an angle made up from the horizontal up to an object. So in this case, these people, they're horizontal up to the object would be an angle of elevation, whereas an angle of depression is an angle from the horizontal down to the line of sight with the object. So an angle down would be an angle of depression, an angle up from the horizontal would be an angle of elevation. In example of 1, we are going to use an angle of depression. The angle of depression of a buoy from the top of the Barnegat Bay Lighthouse, 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. Well, I know so first of all, the angle of depression from the lighthouse is 6 degrees. So from the horizontal, from the lighthouse, the angle of sight down to the buoy is 6 degrees. Now, because opposite interior angles of two parallel lines, the horizontal from the lighthouse and the horizontal from the buoy, the opposite interior angles are congruent. So this angle down here is also 6 degrees. So now I have a triangle where I can set up some trig to solve for the distance between the base of the buoy and the lighthouse. Let's see, I know the angle, I know its opposite side and its adjacent side, so I'm going to say the tangent of 6 degrees is 130 over x. Now I'm going to need to multiply both sides by x. X times the tangent of 6 degrees is 130. Now I'm going to divide both sides by the tangent of 6, and then I'm going to plug this in my calculator, but I got to make sure to be in degree mode, because we are working with degrees in this problem. And when I plug that into my calculator, I get that is about 1,236.87 feet. Let's see, which to me makes sense, because if you have a really tiny angle and this lighthouse is 130 feet tall, it's going to be a very long distance before you actually get that angle of elevation from the buoy to be 130-foot height of the lighthouse. Now, number 3, finding a distance. Similar situation, so I actually copied the picture and just put in the new information. The lighthouse is now 120 feet tall, and the angle of depression from the lighthouse is 10 degrees. So we know that the angle of elevation then from the lighthouse is 10 degrees, and we can set up a tangent equation to also solve for the distance between the lighthouse and the buoy. So I'm going to say the tangent of 10 degrees is the opposite, 120, over adjacent side, so that's x. Multiply both sides by x. X, tangent of 10 degrees is 120. Divide both sides by tangent. And I get x equals, again, making sure to be in degree mode, 120 divided by tangent of 10 degrees. And in my calculator, that's about 680.55 feet. It is going to be shorter. Not only is the lighthouse shorter, but the angle of elevation from the buoy to the lighthouse is bigger. So this buoy is going to be relatively closer than the last problem.